All right, starting up the stream. Why do I hear myself? Because I forgot to mute that. There we go. All right. Days 11 and 12. I need to catch up. So, AoC2023. Have about an hour and 28 minutes to do day 11. I hope it's an easy day, but we never know, right? Okay. Copy day 2, day 10 to day 11. Why is the preview running again? Pause. Bad cop. Hello. How are you doing? I got to catch up. I have like an hour and 28 minutes to get day 11 before day 12 unlocks. Toulouse, how are you doing? Yeah, good luck to anyone else who is doing Evanico tonight, especially if you're caught up and you're ready to do day 12. I'm not yet, so I'm going to try to be. Better go fast. C17R, greetings. Come on, day 11's easy, right? Right? I hope. I'm just gonna put placeholders for parts 1 and 2, and then I think I'm just, once I have this ready, yeah, I'm just gonna copy this and make it day 12 already. Copy paste day 12. Okay, and then in main, we're gonna have a mod day 11 and mod day 12, all ready to go. All right, let's close that. I've been taking a lazy approach to adding each day. A very extremely lazy approach, as you can see. If I was sort of more pedantic, I don't know if that's the right word, like, I would probably spend more time and try to automate this or use a crate that automates this for me, but I don't know. I guess I just feel lazy about this. I just want to have fun, you know? Day 11 should be pretty quick in an actual language. Took you a while? Okay. Yeah, a lot of people do ebb in a code, challenging themselves with like languages that are hard mode languages. Um, I just have so much fun with Rust that I kind of stick with that, you know? Because I don't get to do Rust at all in my day job, so I might as well have fun and be able to work with it on stream, right? It seems kind of hard to type and talk at the same time. Just saying. How come that didn't copy paste? Oh, I have to click down here. Duh. Day 12. Okay, so day 11 needs to actually say day 11, or I would have a hilarious moment trying to figure out why it wasn't actually working. So day 11, day 12, go away. And test has to mention day 11 and a day 12. Okay, so cargo. Next test should run all of them, including days 11 and 12, and all pass because 0 is expected and 0 is output. And I should be able to do a cargo run day 11.1 and get 0. All right. Okay, let's close 12, 10, just leave 11. So we can focus on solving yesterday's problem. Okay. I think if you wanted to actually speed run it, you would do it in JavaScript. I think if I wanted to speed run it, I would pick one of those languages that's been specifically crafted for AoC, where like all the common things that the AoC puzzles have you do, like the parsing, the making grids, making separating numbers, that kind of thing, Could be intrinsic functions, or maybe just have a library where those are already developed, and I would have things set up so I can pull quickly from it. So when I see that the puzzle is like, oh, it's a grid, okay, then pull in the grid library, and the parse, something where you want the parsing to be like done within the first minute, right? And then you can focus on just the thing that makes the problem specific. That's what I would do. Um, I actually got a pretty decent score for day 10 for me, 1569. That's the best this year. I'm averaging around 3,500 when I'm starting on time. These are the days I'm not starting on time, so it's really hard to know how good I would have done. Let's say we're to find someone who took about as much time as I did and compare notes, which I haven't done, but I'm just going off of the days that I have been able to do on time, and I'm averaging 3,500, maybe a little bit higher. I guess on rank 2 I'm doing worse, but yeah, I got a really good score on day 10. That was a fun day. Bash is actually very good for the parsing part. Really? I don't know Bash very well, but my impression would be that it's pretty hard to do anything in Bash that doesn't involve running commands, pipes, and that kind of thing. But yeah, I don't really know. It's interesting though. I guess I wouldn't have thought it. All right, day 11. Cosmic expansion. You continue following signs for hot springs and eventually come across an observatory. An elf within turns out to be a researcher studying cosmic expansion using the giant telescope there. He doesn't know anything about the missing machine parts. He's only visiting for this research project, however. He confirms that the hot springs are the next closest area likely to have people. He'll even take you straight there. Once he's done with today's observation analysis, maybe you can help him with the analysis to speed things up. The researcher has collected a bunch of data and compiled the data into a single giant image. Your puzzle input. The image contains empty space and galaxies. The researcher is trying to figure out the sum of the lengths of the shortest path between every pair of galaxies. Yeah, this actually sounds really familiar. Like there was a puzzle like this in a previous year, right? And I remember it was three-dimensional, and I had a hard time with this. I hope this doesn't go 3D. We'll see. There's a catch. The universe expanded in the time it took the light from those galaxies to reach the observatory. Due to something involving gravitational effects, only some space expands. In fact, the result is that any rows or columns that contain no galaxies should all actually be twice as big. Okay, in the example, 3 columns and 2 rows contain no galaxies, those ones that are marked. Those rows and columns need to be twice as big. Oh, so if there's a column with no galaxies, you just have 2 columns instead of 1. Okay. The result of cosmic expansion, therefore, looks like this. Equipped with this expanded universe, the shortest path between every pair of galaxies can be found. It can help to assign every galaxy a unique number. In these 9 galaxies, there are 36 pairs. Okay. Only count each pair once. Order within the pair doesn't matter. For each pair, find any shortest path between the 2 galaxies using only steps that move up, down, left, or right exactly 1 dot or galaxy at a time. It's allowed to pass through another galaxy. Okay. For example, here is one of the shortest paths between 5 and 9. Okay. This path has length 9 because it takes a minimum of 9 steps. It doesn't really matter because it's just Manhattan distance, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 is the same as going 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it doesn't matter. We just do the Manhattan distance, right? Okay, so it gives us some other examples, like 1 to 7 is 15, 8 to 9 is 5, right? 1, 2, 3, 4, 5. So the sum of the shortest paths is 374. Okay, so, well, there's our example. And then our input was before the expansion, right? So we got to do 2 things. We have to do the expansion, and then we have to do the Manhattan distance between every pair. Okay. So I think the expansion we ought to just do like during parsing if we can. The rows are really easy because those we can just repeat. The columns are going to be harder. So why don't we expand rows during parsing and expand columns as a step after parsing? And we would just we would first identify the columns to expand, and then we would have a list, and then we would for every row we would do that expansion with the same list. Okay, and then there's probably if we remembered the coordinates of every galaxy, that'd probably be the easiest. So maybe after we expand, we would just go through it again and find the galaxies, and then we have to use some algorithm that that selects pairs, and then do Manhattan distance, and then sum them all, right? So like a choose, what is that? Permutation? No, combinations, right? Not permutations. Permutations would be like 1 and 2, and 2 and 1 are different. Combination is 1 and 2, 2, 1 are the same, I think. All right, thinking through the problem. I think we're done thinking through the problem, so let's have a function parse input string. So in the other days, I've had a structure represent the whole thing. I'm wondering if I want to continue to do that. I guess so. I guess so. There's not much harm in it. What is it called? An image. Impl image. I bet I lose a lot of time just typing. So we have self, which is empty right now. Image. So let's do image new, and then we'll run it through expand. Columns. How about image new expand rows, and then expand columns? I'm just thinking in code here. Hey there, Nightshade dude. The pipes from day 10, I had an idea that I really liked that worked out really well for me for part 2, by the way. And that was I did this expand trick. So I decided that for every 1 by 1, every original cell, I would expand it to a 3 by 3, and the pipes just get expanded in the same shapes that they started with. And then after expanding, um, I then did a flood fill, and then after the flood fill was done, I did a contraction again by filtering out all the cells that weren't the center cells, and then it just counted the number of ones that were ground and not flooded, and that worked out really well. And I didn't see anyone else do the same trick. I saw a lot of people trying to figure out ways to count numbers of pipes that you're passing through to see if you can squeeze through, and I'm like, I kind of like my solution better. And it actually was pretty fast. It runs in less than a second. I think it's like a tenth of a second, or 2/10 of a second or something. Anyway, it was nice. Anyway, hey there, Code Monk. Good luck to you. I know Nightshade Dude, Bad Cop, and Code Monk are all doing Advent and Code this year, so hopefully you're all having fun. I'm a little scatterbrained at the moment. What I want to do is parse the input. And then what do I want to do with that? That's going to give us the image that's been expanded. Let's then have it I guess that could be part of parse would be to actually find the galaxies, right? So let's just have it give us the pairs. and then assume that's an iterator of two galaxy positions, and then we would want to map that to Manhattan distance, right? And then sum them, right? So let's make a Manhattan distance. T. I guess we don't need to make it generic. Mm, use tuples, right? I'm using U64s because that's what my main function is sort of expecting. So that's the absolute value of the difference, right? So let me think about this. Well, really, it's A dot 0 as U64 minus B dot 0 as U64. That absolute value. Oh, there's an absolute difference? What does that do? Computes the absolute difference between self and another. I want to see that example, but it says basic usage and then it stops. Basic usage. Uh, I guess I'll just look at the manual. What is it again? Abs diff. Oh, that's exactly what I want. So I don't even need to do that. I would just do a dot yeah, a dot 0 dot abs diff b dot 0 that as u64 plus. Really having trouble with my keyboard today. This is Manhattan distance. You just add the difference of the two coordinates. I guess I didn't need a parentheses there. Okay, and then pairs. We need to define what pairs does on an image. So function pairs. I guess we can make that consume self. Sure. So some kind of iterator. Actually, I'm thinking then that it would be easier if we did it this way, or the item equals u size, u size. Two of them, right? And actually, if I'm gonna map it through, really, there are this should be like points, and there are two of them. This is ugly, but you know what? That's fine. Actually, what am I doing? A dot is points dot 0 dot, and then B dot is points dot 1 dot. Okay, that's horrible, but it's okay. I'm abusing the type system. It doesn't like that. It looks okay to me. Probably because I haven't hit save yet. Yeah. Okay, so I also it doesn't like like you can't do it to do with that. So I have to actually make an enumerator. Struct. Actually, it's easier. It actually is easier if I do it this way. So struct uh, oh, oh, is that okay? Hold on a sec. Pairs. I was thinking it would be easiest to just put it in here. And then what, like an index? Okay, I need well, this is just pairs then. Image is self, index is 0. In order to do this, I have to implement iterator for pairs. Actually, I don't know if this is the best way to go about it, but we'll see how this works. I could just copy this, right? There we go. All right, so I need an expand rows and expand columns. New expand rows. And then I have to expand, they call it columns? Yep. Self. Self. All right, what else? Takes one argument. It does. It's the input. All right. Yeah, so I was thinking that this would first start off with let mute this equal self new input. We would do something to it and then we would return this. And this is just going to be actually, when I think about it, we don't really need to hold on to all of the points. We only really need to remember the coordinates of all the galaxies, right? And we'd have to maybe we'd also remember which columns and rows are filled in or are still empty. So, or actually, the other way to think about it is which rows and columns have galaxies in them would be fixed. So that makes, if that means the data structure that I really want it internally to be is like galaxies is well, no, not galaxies. Well, there's three of them actually. Galaxies is going to be a hash set of positions, and then we're going to have like galaxy rows. I guess rows and columns would be populated, right? Hash set um just thinking, is this the right, are these the right data structures? I think so. All right. So we're going to let it's easiest to just build them, right? So just start with these and then autofill that. And then here we would do input, lines input, right? Enumerate for y and line in that for x and what is it? What do they call it there? Space. Here it's going to be line dot chars dot enumerate, right? Then if space equals galaxy, we're going to do three things really. Galaxies, insert x, y, and then rows, insert x, no, y, calls insert x. This has to be static. Okay. Actually, why does that need to be static? What is escaping here? What's borrowed here? I don't really see it escaping, but that's okay. I won't spend my very many brain cycles on that. Okay, so that does the root parsing. But when we expand, actually, why don't I just combine the two? New expanded. Same thing, right? What's the error here? Again. Right, no expand columns needed. Okay, so I guess we do the rows and the columns, and we're gonna basically be forming a new set of galaxies. So let's make mute galaxies equal hash set new, and then standard swap, mem swap galaxies and this galaxies. And then for x, y in galaxies dot, this doesn't need to be mutable. Actually, hold on. I don't need to do this swap. I can do this dot galaxies because we're going to form a new self. Yeah. Actually, now that I think about it, after we've expanded it, we don't need the rows and columns anymore. That's okay. So we'll just keep them even though we don't need them. We're going to form a new galaxy. Yes. We'll form new galaxies. We're going to expand the galaxies, really. So if I were to expand this, it doesn't know what to put for rows. it's going to be this dot rows and this dot columns. So really this we should be called unexpanded. Actually, you know what I think I'd do is I'll just do new dot expand. Move the input to new. That seems more natural to me. This one's now expand, and it's unexpanded or self. So unexpanded is self. All right. So then actually before we do this, we have to find out where the spaces are. One thing I need to do is we need to stop when we hit the edge. So I'm actually inclined to just take the number of rows and then the number of rows that have galaxies, the number of columns that have galaxies, and take that back. It would be good to know the highest row and the highest column while we're building it, right? So we'll just call this one populated rows. No, let's just do num rows. The names are bad, but that's okay. So I need to actually make something for that. Start off with 0. What happened here? Okay, never mind. So actually, I don't even need to compute these, do I? No, lines gives me an enumerator. So I do need to have this. It sucks, but that's okay. Num. Actually, why don't I just add equal 1 here? And then num calls equals line length. This is going to be redundantly computed every time. I don't care. It's fine. It's all fine. Num rows. So that's self num rows plus, actually, so do we expand it by the number of unpopulated rows? That's going to be the difference between the number of rows and the number of populated rows, right? So that's going to be num rows plus self num rows minus self rows length. So it's that times 2 minus that. And same thing for the columns. Not that actually we need this, but that's what it is. Right? Okay. So given that, given a position of a galaxy, we need to like answer the question: how many spaces are there before and after before it in columns and rows, right? To know how much to shift it over. It's making me rethink my data structure here. Because if it instead was like a hash map, better yet, if it was a vector of y's and columns, and each column was how many was its position, that would make this so much easier. Okay, then yeah, let's make this a vector of u size and vectors of u size. So this is the row number and this is the column number. Row number, column number. Okay. So that means that we're going to construct something here, right? Let row is vector new. Let mutable row is vec new. If this is true, then row push x. And then if we get down to here, if not row is empty, galaxies push row. So this is a vector new now. Oh, it has to be a tuple, y and row, because we have some empty rows. Okay, so that structure being that, then this is now a y and this is a row. Uh, we need to have like a running count of how many rows to skip, right? And so let's mute skip row, or how about y offset, yo 0. And then let's have a space, an sy. So the while sy, this is the space. My names are terrible. My apologies. But while sy is less than y. Hey there, Tim. Good night, Tim. You saw me live and said hello world. Hello world, back to you. Doing Ebony code, and I have less than an hour to catch up to day 12. I'm doing day 11. And I missed some people chatting. Nightshade Dude finished with day 4 in Erlang. Might start on day 5 tonight. May just work some. Good job, Nightshade Dude. Okay, so while space-wise, so we need to have it catch up, right? Let's have it advance by 1. No. We'll have it advance at the end. There. But if it's if y is ahead of this current space y, then we have to actually it doesn't even need to be a while. You're going to advance the offset by the difference between y and space y. That's the amount to offset it, right? And then it's going to be for x in row. We're going to do the similar thing. So let mute x offset equal 0. And x offset plus equal, I need to have another variable, right? Mute sx equals 0. X offset is the difference between x and space x. Space x. Woohoo! We're going to Mars. And then at the end, it's space x plus equal 1. But in the meantime, we also have to form the new row. New row equals... Actually, why can't I just do a map then? Why can't I do a yeah, can't I just absorb it? So let row equal row dot map x, and when that's done, galaxy actually then galaxies is going to be a mapping, right? Yeah, galaxies equal this dot map y and row to something. Okay. So then what we're mapping each row, what mapping each input row to is an output row. So that's going to be the new y. So that's y plus y offset, right? I hope this is right. And then the new row. And then here it's a similar thing, right? So we're going to map the x to um, x plus x offset. I have to do a collect at the end. And this also needs to be a collect, right? Right here. Why does it not like this? Because this has to do into iterator. Close respect to take a single two tuple. Oh, yes. Single two tuple argument. There you go. I don't need those parentheses. Yeah, this is into iterator. No parentheses. I hope I got my logic correct. I guess the way we'll test this is we'll just print out all of the galaxy positions before we do anything else, right? So that would be like DBG here. Okay. Expanded. Yeah. Oh, this already consumed rows and columns. Oh, right there. Yeah, so we need to get like let um old num rows equals this. That's old num rows. Don't think we need to really worry about this one, but I'm going to do it anyway, because why not? This we don't even really need them anymore. It's sort of pointless to do this. We don't really, Paris is only going to use galaxies, but that's okay. Um, let's see what I get right now. Just I want to verify that we're doing the expansion correctly. So we have 0 and 6. 0, 1, 2, 3, 4. It should have been 4, not 6. Instead of 3, it should be 4. Why did it do 6? Okay, we have a bug already. It pushed that by 2 instead of 1. Probably because I'm off by 1 here somewhere. Oh, wait. I can't be looking at for columns, we don't want to look at yeah. Actually for rows too. This is wrong. This and this are both wrong. I do need a while loop. We basically have to walk through. This is the whole point of having these rows and columns. And then actually, yeah. So we want to see if there's anything, if such something in there. Yep. Okay. So then this is while um or really for I need some temporary variable yy in uh sy to y if um not self rows contains yy, then sy plus equal 1. No, y offset. Okay, and then I need the same thing for the x here. Only it's x's instead of y's. And this is columns instead of rows. Okay, now let's see if I got it. 0, 4. Okay. And then 1, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's correct. And then 0, 2 should be next. Or 2, 2, 0 should be next. And then 5, 8. 3, 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Yeah, that's right. And then 6, 1. And then 7, 12. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11. That's correct. 8, 9. So 10 and I think that's 9. 10, 9. Yep. And then 12 has got 0 and 5 in it. 1, 2, 3. Cool. Okay, we did it. So expand is correct. We have proven out by debugging we can trust the expand. Okay, so expand is correct. You just need to do the pairs now. So this is really just walking through combinations of galaxies, right? So galaxies being so I really just need to reduce this into a bunch of galaxies, and then there should be like a combinations. Is there like a combinations function in Rust? We were using this um, crate, right? Of course we're using a crate. Using this num crate. I wonder if num has like a combinations. That would be awesome. Let's ask find. Uh, how do you enumerate com combinations of items from an iterator in Rust? Let the large language model answer it for us. Hey, there's the of Adam. Iter tools? Yep, iter tools it is. Combination function generates all combinations of a certain length from an iterator. Cool. So we're going to pull in iter tools. Because why solve it when we can just pick up code that solves it for us, right? So large language model thought it was at 0.10. No, it is at 0.12 now. Cool. Now that we have the iter tools, I should be able to just say like, well, we have to flatten this, right? So rather than an image, I think I just want to grab the Don't I just want to pull it out? Actually, do I even need to make a pairs? I don't even think I need to. Yeah, I don't think this is needed. We're just going to do self dot galaxies dot flat map or into iter flat map given a y and a row. Take the row into iter and map the x's to x and y. That gives me, let's see what that gives me. I think that's correct, although it didn't give me the complete type, but I think the item is coordinates of every single one. So given those coordinates, then I want to do the secret combinations. Combinations with replacement? Tuple combinations? This one's just said to do combinations. Combinations 2. Sure. It yields a vector. Expected a vector, found tuple. Why is it generating a vector? I guess I should look and see how combinations works. Or I can look and see how did they say it here. It should give me an iterator though, right? Okay. Can I just like look up iter tools? Yes, I can. And they can do combinations. Iter tools combinations. Here we go. Return an iterator adapter that iterates over k-length combinations of elements from an iterator. Iterator element type is vector of item. The iterator produces a new vector and oh, I see. I gotta map the vector into. So there was like a tuple combinations I saw, right? Tuple combinations. Is that what we want? Yeah, yeah. So I want tuple combinations. It did not take. Oh, can turn any homogeneous item of size. Okay, so it just gets it from its context. Okay, and then we just have an error here. Yeah, we want to move to take a copy of y. Perfect. Okay, so that gives us pairs, right? Let's just see if it works. It didn't. I got 388 instead of 374. Okay. I guess we want to like print them all out or something. So let's dbg points and see it there. Let's make sure that it's actually giving us all the combinations. I wonder if it's giving us permutations and not combinations. So you get 40 and 91, 40 and 02, 40 and 85, 40 and 16, 40 and 12, 7, 40 and 9 and 10. I can't tell if it's giving me permutations or combinations. Feel like you also got 388 is the wrong answer on the test input. We don't remember what you did. Maybe I misread this. It's okay. We should verify there are 36 pairs. So what's the easiest way of doing that? Like giving me instead of a Manhattan distance, we do a count or something as U64, and it should give me 36, right? 36 pairs. Yeah, so there are 36 pairs, but maybe I'm just not doing the Manhattan distance correctly. How do we get spaces there? That's weird. It's insisting on putting spaces there. Okay, so let distance equal that. It's just so I can do this, points and distance. Four zero nine one. Wait. Oh, that's Galaxy 1 is 40. 91 is 2. That should be 1, 2, 3, 4, 5, 6. It is 6. Okay, 40 to 02. That's over there. 40 to 85. So one of them is 15, right? Yeah, here it is. 12, 12, 7. Yeah. 1, 2, 3, 4, 5, 6, 7. Am I thinking it's not Manhattan distance? Did I misread one of these? Up, down, left, or right, exactly one. So that is Manhattan distance, right? It doesn't have to be like a straightish line. You can do any path, right? Yeah, it is Manhattan distance. So what am I doing wrong? Did they give us the wrong number for the example? That that couldn't be, could it? 374 is correct. Then why am I getting 388? So I get a difference of 14 for some reason. So I'm guessing I screwed up in the expansion somewhere. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, wait a minute. It's not 12. It's not 12. It's 11. I think the last row is wrong. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, oh, we're wrong. It got 12 where it should have gotten 11. So the last step was wrong. Okay, let's go back. Let's look at this again. Where was it that I was debugging? Right here, I guess. Debug galaxies. Oh, can I not do that? I forgot where I actually put the DBG before. Okay, here we go. So 0 has 4. Let's see where the bug is. 0 has 4. That's correct. 1 has 9. 5, 6, 7, 8, 9. That's correct. 2 has 0. 5 is 8. 2, 3, 4, 5 is 8. And then 6 has 1. 7 has 12. 1, 2, 3, 4, 5, 6 is 1. 7 is 12. Then 8, 9, 10 is 9. Okay, so we skipped 11 somehow. Why did we skip 11? We skipped it for some reason. Let me try to think. The skipping is done here. This I might as well have done up here. Let's print out what rows is. Ah, all right, run that. Zero, 1, 2, 3, 4, 5, 6, 8, and 9. Am I looking at the new space and not the original space? Is that the problem? I think that's what the problem is. Let's remove this. Let's just actually print out when we get into expand here. Ah, let's print out y, yy, and sy. For sy, y, and yy. So 3, 4, 3, 6, 8, 7, 7, 9, 7. So the original, right? 0, 1, 2. So row 3, 4, 5, 6. Actually, it's 7. Oh. They're old and new coordinate systems, right? That's the problem. Okay, I think I get what the problem is. Wait. How did this work then if the other one didn't? This is catching all the rows that we skipped, right? For all the skipped rows. I think I might see the problem. This is in the wrong spot. This has to be in here. There's no plus equal 1. Yeah, this doesn't make sense. So this is just 0 to y. Yeah. then I didn't really need to. I could have used the more simplified. Okay, this takes advantage of the fact that these are in order, right? So that it can do it that way. But I don't know if this +1 is correct. I don't think that is correct. Shouldn't that be equal x? Yeah, I think it should be. All right, let's see if I get the right answer now. No, now we're too high. Dang it. Okay, our column numbers are wrong now. Sorry, our row numbers are wrong. 0, 1, 2, 5. 0, 1, 2. It's off by it's 1 too high. Oh shoot. Yeah. Hold on. This needs to go in there. Okay. Finally. Okay, we got the right answer. So then I can run, well, I need to get rid of the debugging statements, or else it's going to go crazy. I also have to get my input. Yarr. Do you think I can get part 2 in 20 minutes? Probably not, right? I'm taking way too long to do part 1. Okay. Oh, I don't have our input. Get your puzzle input. Paste your puzzle input. Run your puzzle. There's a large number. Copy. Paste. Submit. Yay, we got it. Part 2. I got 20 minutes to do this. The galaxies are much older and thus much farther apart than the researcher initially estimated. Now, instead of the expansion you did before, make each empty row or column 1 million times larger. That is, each empty row should be replaced with 1 million empty rows. Each empty column should be replaced with 1 million empty columns. The example above, if each empty row and column were merely 10 times larger, the sum of the shortest paths between each pair of galaxies would be 1,035. Actually, we're going to get this really fast, aren't we? Because I just replace my 1 with 1 million, right? If each entity in the column were merely... Okay, so let's just parameterize it then. So they said that it was that. So this is going to be difficult because I only have one input. I guess we'll do in the main we could yeah, so I'll just say that that's a 1, and then that is a actually it's only part 2 that needs this number, right? Part 2 will have 100, no, 1,000,000 when we run it for real, right? It'll have 1,000,000, but when we're testing it, it'll only have 100. So that we can get that number, right? So part 2 needs another number, which is the like expansion or factor. So it's the same thing, only oops. The parse is going to take the factor, and part 1 it'll take a 1. Parse itself has a factor. U64. The expanded takes a factor. Expanded takes a factor, and that's factor and factor, right? Oh, it's got to be a U size. Well, yeah. As long as we don't get to 4 billion, we should be fine, right? Okay, so then the original one should still work. Now, does the new one work? No. We're off by a little bit. We're only off by a little bit, though. That's concerning. Oh, it's factor -1, right? So, this should be 99, I think. Yes. Okay, so when we run it for real, it's got to be 999,999. And there's our number. Copy. Paste. Yay! We did it. That was extremely satisfying. That all we had to do was take a constant in our part 1 solution and replace it with a variable. That was nice. Actually, a better way to do it would be to do a 0 here. And when we get to in parse here, expanded, we should just add 1. And then change this to 100. And change this to back to 1,000,000. It wasn't +1, was it? It was -1. Plus, no. Hold on, let me think about this. This would be a 2. Subtract 1. I just wanted to be like where 0 was the default. Yeah. So it's like how much to make one space. One space becomes 2 in part 1. One space becomes either 100 or 1,000,000 in part 2, depending on if it's the test or the real thing. We get the same answer. Yes. Cool. I have a warning I need to fix. Where is this warning? In day 12, because we haven't done day 12 yet. Oh, cool. So we have 15 minutes. Yay. So how did everyone do on day 11? Yeah, so that's what we'd expect, right? That part 2 didn't really take much longer than part 1. So like if the median time for the top 100 was 5 minutes and 14 seconds, the median for part 2 should be just a little bit more. Really? I would expect that the median time would have been like maybe only 1 minute more than the median time for part 1. That's weird. Huh. Okay. So it was enough to trip up the speed coders by 2 minutes. Actually, if I probably roll back how long it took me, it probably took way more than 2 minutes, right? So you have to take my speed and multiply by at least 5, if not 10, to get the speed coders time or speed. All right. Yeah, my personal times are gonna suck. It's almost a day behind. I think probably by after a day, really the only difference between rank 1 and rank for part 1, rank for part 2 is how many people only did part 1 and not gave up on part 2. So being very close, that tells me that most people did both parts. And we'd probably see that if I did stats, right? Yeah, so most people did both parts. Day 9, almost everyone did both parts. So day 10, we had like, this is like the give up factor, right? I didn't think day 10 was that hard. Day 5 was pretty hard. I can understand that there's a big chunk out of that 2-star pile. There are a lot of people who gave up on part 2 of day 5. Yeah, and we're going to see this trend of like drop off, right? As people don't keep up or they give up. And it's kind of hard to tell unless we look day after day to see some of these numbers are still going up probably because just people are doing it late versus the number of people who just kind of gave up. But yeah, thank you, Code Monk and Lieutenant Hummus and Nightshade Dude. You gave up on day -1? Yeah, I mean, that was tough. That one you couldn't even find where to click it. Day 0 was hard enough to find. So, 12 minutes. What do I do for 12 minutes? Probably just clean up what I wrote in day 11, right? That I'm going to accept. That will accept. Okay. So I didn't like that the expanded needed to do this chunk when all we really needed out of it was the galaxy. So what if we just have expanded give us back something else? Um, yeah, what if we just make uh, type galaxies equal this, right? So this is a galaxies. Let's just have the expanded return galaxies, right? So then I don't need to do any of this let. I just do self galaxies into iterator map and then collect and we're done, right? And then we'll just implement pairs for galaxy. Can I do that? Can I do impl galaxies? I cannot do that, but I can do a new type. So we do struct galaxies and then do this cool thing. And then I can do an impl. And then I can move the pairs there. It's just that for this, I'll need to do galaxies and then that, right? Okay, and then pairs goes away. This returns a galaxies. Why is this wrong? Galaxies is not an iterator. Oh, dot zero. Okay. So this is galaxies. And this is self dot zero. Cool. So then we don't need num rows or columns. Nice. Didn't need any of that crap. I like it. So why did I close my unit tests? I don't know. Got a lot of days. Let's run them, make sure that it still works. Cool. So clean up. Kind of clumsy that we have to do a dot zero in galaxies. So I wonder if I could like actually give it a new. Just have it take the vector directly. Also, we could probably clean this up. Don't need this anymore. Looks like we're doing man and distance sum twice. So why don't I just have pairs do that? So pairs can return just directly a U64, and we just do that, right? So I'll probably need to rename it. It's not pairs anymore. What would it be? Distance sum? Manhattan distance sum? Something like that. Okay, and then why not just have parse return the U64 directly, and we just do that there and do that, and then we just call parse solve. Manhattan distance doesn't really belong there anymore. It kind of belongs up here. Um, got 5 minutes or so. Let's clean this up. So this is self galaxies. Let's have a let's have a new and a push. That's all we really needed, right? So that's just self fill with vec new, and then let's have a push. Self and galaxy. So if we have time, I think what we're going to do is we're going to actually make a type name for that. That's self.galaxies dot um, push galaxy. Oh, shoot, it was this. That's like a row. Okay. So then this goes away. This is just a galaxies new. Okay, and so why don't we just make this a method on galaxies itself, and we give it its give it the rows and columns. So expand ed rows is actually hold on, paste that code before I lose it. I want to grab this and paste it there, and this would be self galaxies is self dot galaxies into iter. Okay, self rows becomes rows. This needs a factor. So factor, here we go. Factor, there you go. So this just becomes self.galaxies.expanded factor self rows self columns, right? Yes. Cool. I like refactoring Rust. It's so satisfying. Uh, it's easy to like move things around and move types around and redefine things. I got 2 minutes and change. Anything else I can do to clean this up? Kind of want to make a formal type for that, like a galaxy image row or something, or just call it row. Maybe just for now, just give it a name. This is a row right here. So this is just a vector. Well, that's a vector of rows, and this is a row. So this is a row. This is just called, this should be just called rows. What else can I do here? This, we can unindent this. I got a minute and change. I could just say, let rows equal that, and then rows, so that doesn't get indented as much. Okay. Really, these should be cleaned up, right? Into like smaller functions, but that's okay. Yes, good luck everybody who's doing day 12 on time. Should just get set. I have less than a minute left. Make sure that everything is still in good condition. That everything's still passing. All right, and then close day 11. I got a minute left. Day 12, just open it up. Close that, close that. We're going to focus on, oh, where did my test go? We're going to focus on making the test from the puzzles. So, if you're just joining us, we're going to do live as it unlocks, midnight Eastern time, AvaCode day 12. So we get programming puzzles, 2 parts, um, one one pair each from January 1st to 25th. They're Christmas themed, so they're all going to be whimsical, made up, contrived examples just to as a challenge that we have to write a program to get an answer from a bunch of input. So I like to read through the puzzles. I'm kind of slow. I'm not a speed coder. Don't expect me to get on the global leaderboard. We're just here to have fun and do some Rust. So here we go. Day 12. You finally reach the hot springs. You can see steam rising from secluded areas attached to the primary ornate building. As you turn to enter, the researcher stops you. Wait! I thought you were looking for the hot springs, weren't you? You indicate that this definitely looks like hot springs to you. Oh, sorry, common mistake. This is actually the onsen. What's an onsen? It's a bath. Okay. The hot springs are next door. You look in the direction the researcher is pointing and suddenly notice the massive metal helixes towering overhead. This way, it only takes you a few more steps to reach the main gate of the massive fenced-off area containing the springs. You go through the gate and into a small administrative building. Hello, what brings you to the hot springs today? Sorry, they're not very hot right now. We're having a lava shortage at the moment. You ask about the missing... So the next island is a lava island, don't you think? You ask about the missing machine parts for Desert Island. Oh, all of Gear Island is currently offline. Nothing is being manufactured at the moment. Not until we get more lava to heat our forges and our springs. The springs aren't very springy unless they're hot. Say, could you go up and see why the lava stopped flowing? The springs are too cold for normal operation, but we should be able to find one springy enough to launch you up there. There's just one problem. Isn't onsen just Japanese hot springs? I guess. But it's more of like the baths that are made from hot springs, right? Just one problem. Many of the springs have fallen into disrepair, so they're not actually sure which springs would even be safe to use. Worse yet, records their condition records of which springs are damaged, your puzzle input, are also damaged. You need to help them repair the damage records. In the giant field just outside, the springs are arranged into rows. For each row, the condition records show every spring and whether it's operational or damaged. This is the part of the condition records that is itself damaged. For some springs, it's simply unknown whether the spring is operational or damaged. However, the engineer produced the condition records also duplicated some of this information in a different format. After the list of springs for a given row, the size of each continuous group of damaged springs is listed in the order those groups appear in the row. Okay. This list always accounts for every damaged spring, and each number is the entire size of its contiguous group. That is, groups are always separated by at least one operational spring. Would always be so 4 in a row would always be 4, never 2, 2. Okay, so condition records with no unknown spring conditions might look like this. Okay, this is 1, 1, and 3. 1, 1, 3, 1, 3, 1, 6. So it's an unknown number of operational springs, followed by the number of damaged ones. So it's like 1, some number, 1, some number, and then 3. Okay, got it. However, the condition records are partially damaged. Oh no. Oh right, we knew that. It's not that those numbers are damaged, it's that our input is really damaged. Some of the springs conditions are actually unknown. For example, well, I don't know. 3, 3, 3. So, equipped with information. Sorry, I need to take a drink. Equipped with this information, it's your job to figure out how many different arrangements of operational and broken springs fit the given criteria in each row. In the first line, there's exactly one way separate groups of 1, 1, and 3 broken springs in that order can appear in that row. The first 3 unknown springs must be broken, then operational, and then broken, making the whole row that. So it's really a question of find the number of operational springs between the groups, right? The second line is more interesting, right? Because that one at the end, well, you have to fit the ones you know, right? Could be a total of 4 different arrangements. The question mark must always be broken to satisfy the final contiguous group of 3 broken springs. And each double question mark must hide exactly one of the 2. Right. So there are 4 possible arrangements. The last line is actually consistent with 10 different arrangements. Because the first number is 3, the first and second must both be a dot, blah, blah, blah. Actually, I should read this because it's probably important. Because the first number is 3, the first and second question mark must both be a dot. First and second question mark must both be a dot. Oh, because if they weren't, it would be a 4. However, the remaining run of unknown spring conditions have many different ways they could hold groups of 2 and 1. Yes, so this is actually them being enumerated, right? The number of possible arrangements for each row is 1, 4, 1, 4, and 10. Okay, so at least I know the outer part of the puzzle. So given this, that's the example. The answer is 21. So I know that we're taking the sum of a solution for a row. So I can just say lines input map solve and then sum them, right? So we have function solve input. So I've done that part. So within each row, so they're all independent of each other. Here's the hard part, right? How do we do this? Well, we first need to do the easy part, which is parsing. We're gonna split on a space. Let's put a to do here at the end. Let springs, and this is the count of groups, I guess, equals input dot split once on space unzip or unwrap, right? And then let springs equal springs chars collect. I'm just gonna be lazy and make a vector of characters. Let our groups equal groups split on a comma, and then map through string parse flat map so we can not deal with options. What's this one? Yes. Map it through string parse and then collect it again into a vector, because why not? We have to say what, so we'll do 64s. Okay, so now we got our vectors of characters and numbers. Now we got to decide how we're gonna solve this dang thing. Oh gosh, I don't know. So, like the way this was solved is like, I guess if we take the largest number and try to fit it somewhere, would maybe, so we would just find the place where it fits. And I guess could we just take the first number and try to do a fit on the first number? So what about this first row? I guess we would say it try fitting it there, then try fitting it there, then try fitting it there, and then just be recursive about it. After fitting, try fitting the next one. So if we try to if we use the one and fit it there, the next one, so with the rest of the list, it would try to fit into that. The one won't fit anywhere because it has to be a one with nothing adjacent to it, nothing or a dot adjacent to it, right? So it would quickly abort back out. If you put one there, same problem. Same problem. Because we would assume that that's a so if we fit the first hash mark there, we expect that the other ones are all dots, and then give it this remainder. Okay, so then the only one where it actually works is if you fit the first one there. This is what you get for 1, 3, and then it fits the one there, and it's done. So what about the one with 4 arrangements? This one. So it could fit it there, or it could fit it. So 1, 1, 3. Yeah, I can see that. I can see how it would work. How about the one where it was 3, 2, 1? Okay, so the fit thing, it can't fit there because that's not a dot. It's basically got to look at all the possible positions scanning from left to right and see if any rules are broken to the left or right, right? So fitting it there doesn't work because that breaks a rule. Fitting it there works. Fitting it there doesn't work because of that rule. And fitting it anywhere else Actually, we would stop. We would stop if to the left we have a hash mark. We would stop trying to fit, right? Because then it's none of the others are going to fit either. So yeah, that's the only place where it fits. Right, but then the 2 1 could fit exactly. This is actually how we would how our recursive thing would work. It would walk it this way. It would try fit there and then try to fit the 1 and it would find all 4 solutions, and then we would scan to the right and then find 3 more, scan to the right, find 2 more, scan to the right, find 1 more. Okay, so I think this will work for at least part 1. So it's going to be a recursive fit thing, right? So it's going to be it's going to be the answer to fit springs groups. Well, it's going to fit all the springs. Yes, fit all of the springs with all of the groups. Right? So fit takes some springs, char, and some groups, U64s, and returns a U64. Okay, and this is the recursive part, right? So I think what we're just going to do is um, for an index in 0 to the spring's length minus, oh, we have to pick off the first group, right? Let group equal groups first, unwrap. And let next groups equal the slice of groups from 1 to groups length. And if this is empty, then we only need to fit the group into the springs. So if it's not empty, we have to do a recursive call. Right. So this is actually going to be a count, right? It's going to be 0 till group length. No, yeah, group is we can do a copy. U64, right? So actually, this would be much easier if U64s were all, if this was a U size. Not all of them, but just this one. So it's a U size and then a slice of U sizes. Okay, so because length is going to give me a U size. This is minus group. So if like there are 4 springs, so this is minus 1 again, right? So if there are if the group is 1 and there are 3 springs, then there's only one position. Actually, that's not true. Um, it should be not minus 1. If if there are 3 springs and the group size is 1, there are 3 positions, so it should be 0, 1, and 2. So okay, then this should be mine a plus 1. So 3 minus 1 plus 1 is 0 to 3, 0, 1, and 2. So this is fold 0 and then accumulation and position. So this is if. So if it fits, right? So actually, I want to have an early exit. So this would be a lot easier if I just had a accumulation. And then did a 4 position in. Because we want an early exit if we see a damaged spring, right? So like when we're fitting the 3 into this, um, we can try that. Um, and we'll skip it because that is not a dot. We can try this because either way it's fine, but we can't try this because the character to the left is damaged. So basically we're going to see if the character to the left is damaged, we want to immediately return. So if position is greater than 0 and springs position -1 equals damaged spring, then return accumulator. If we get this far, we're going to return the accumulator. Okay. This is saying I don't need parentheses. That's fine. Okay, so then that's checking to the left. That doesn't violate a left rule. Now we got to check to the right. If position +1 is still less than spring's length, and springs, it's not actually +1, it's plus group. And springs group, well, position plus group is equal to a damaged spring. Then we want to skip it, right? Continue. But if we get to this, then it actually fits. And then we want to take the number of ways. So we want to call it recursively and add it to the accumulator. So if so, that means that I really should have an option here. So this is sum. Actually, this is break. And because if let sum subfit, actually, this is also going to be if next groups. Actually, I could just have it here. If groups is empty, return none. Right? Or no, return sum 0. Yeah, because if there's no more groups to fit. Oh, wait, no. This is only sum if there are no more damaged springs. So this should be return it if there are damaged springs, it's none. It doesn't count. It's not a fit. If there are no more damaged springs, so if groups dot contains, no, not groups, springs. If springs contains a damaged spring, then return none. Else return sum 0. So there are no more no, it would be sum 1, right? Yeah. So there's one combination. That means everything is fit. Why does it not like that? I have to borrow a character? Funny. Okay, so that handles the empty case. So then I don't have to have an if. I just say if let some sub fit equals fit. I want the springs from position plus group to springs dot length. And for and the other one's next groups, right? No. Yes, yes, next groups. Excuse me. I think I might need a cough drop again. Then we add it to the accumulator. Right? So this is that unwrap. Could we better at least fit something? Actually, it should just be unwrap. Or actually, I don't even, I don't even need to make it an option. I can just make this return, always return something. And this, let's see, just return 0 or 1. And return the accumulator if we get that far. Yeah, it doesn't fit if we can't find, if we end up breaking and continuing, it means we didn't fit it. So that just means accumulator is plus equal to this recursive call. Easy. Okay, let's see if I got it. Run it. Nope. Subtract with overflow. Subtract with overflow right there. Okay, what did I do wrong here? So, oh, yeah, so if there's no more room to fit it at all, we should, yeah, we should have a check for that. If springs.length is less than, if it can't fit because it's just not big enough at all, so that's group. Return 0. It doesn't fit because it's not even big enough for the one group. Okay, try again. 133? What? Okay, so we need I guess DBG here to start with. Oh, you know what? I need to skip the dot. Yeah, I think I know why. It's too many. It's too many groups we're considering. Yeah, I forgot. We have to add one. Um, the this fit here. It should be position plus group plus 1. That might overflow, but let's see. Yep. We have a slight, yeah. So I need to do, that means I need to do an extra check. So if position plus group, I already did a check there. So why don't I just break this check up then? So I turn this into if it's, no, that we definitely want to continue. So this should be like an or. Right. And it should be if that plus 1, 0 plus 3. Let's say the whole length of the springs is 3 and we only have one group to fit, right? And it's 3. So that's exactly right. So 0 plus 3 plus 1 would be, no, so then it's that if it's greater than. Yeah. Plus 1. If it exactly fits, this would be too long. So this should really only be done if next groups is not empty. Then that means I really don't need this empty check, do I? No, I still need that because we could run out of groups. Yeah, so what do I want to say here? Yeah, if we'll just say if next groups is not empty. No, I still need to have that. Shoot. What do I do here? I could add a dot to the end of every line. Hold on. So return that to the way it was. If I just cheat and add a dot at the end. So if we do chars and we do chain standard iter once one dot, right? So that we don't fall off the edge. Still going off the edge. We have 1 and we have 64 for the second group. That's not good. Can I do like dbg? Can I do like a groups and make that a tuple? No. dbg groups. Yeah, I want to see that. Just want to make sure it's parsing those groups correctly. 113. Hold on, I can't see them all at once. 113, 113, 113, 16, and 411. 6411, and that's where we panicked. So it saw 64 fits for the second line. That's not good. Oh, I know why. Because we didn't check interior. Interior has to be not a dot. Okay. Oh, yeah, I forgot that condition. But also this starting at 4 but ending, that happened in the 411 group. 3. I thought I fixed that by cheating. Okay, so we won't cheat. We'll just fix this correctly. Um, yeah, this is the left rule. This is the right rule. So then, really, we should say if next groups is empty. That means I don't really need this check at all. Or I'm moving this check, really. I'm moving this check. To not. And then this is just accumulate plus equal 1. Delete all of this. Else. But this has to be if there's actually room for it, right? If position plus group plus 1 is less than or equal to spring's length. Unnecessary. Oh, because I can just do a less than. There we go. Is this a coding visualizer session? No, this is an Advent to code solving session. Oh, why does my bot not know about AoC? Requires more access. What? It doesn't know that I'm the streamer? It says I need access level 99. Weird. Do I have a today command? Access? Yeah. I guess my command is disabled for some reason. Yeah, we're solving Advent to code. So here's the puzzle we're solving. So there's a puzzle every day from December 1st to 25th. And we're just trying to solve it. You generally have to write a computer program to solve these. You can't do them by hand because although you can solve by hand their example, when you get your actual puzzle input, it's like a huge thing that this would take you way too long to do by hand. So yeah, we're writing a program to solve it. But since I was, already just looking at it, might as well just paste my actual input, which we'll be using later. So we're doing a test-driven development. Basically, they gave us an example input here, and it says, well, for this input, you should get an output of 21, and we're just making our test pass, and then running the program with the real input to get the answer that we're gonna solve. And if we guess the answer correctly, the answer that goes with the input, then we get a star. Yay! You can get up to 2 stars per day because there are 2 parts to the problem. Yes, so I didn't do. Let me make sure this at least doesn't panic now. But this is gonna count too high, I think. Yeah, well, it's counting too low. Oh, it didn't think it fit it didn't fit at all. That's weird. 113 didn't fit at all. Let's have it print out like what it's trying when it fits. So we'll have it print here. Springs groups. Actually, what I'd rather do is at this point debug position springs and groups. It's too much input. Um, can I like turn that back into a string? I think I can. Close that. Um, can I like do iter collect into string? Since we're just debugging, that should be fine, right? Should give me like a nicer looking output. Yeah, there we go. So position 0. This is the outermost call, right? It's saying try to fit these groups into that string. So then the recursive call will be try to fit. Okay, so that's fit a 1 and a 3 into that. So then the next one should be. Oh, it bailed. Why did it bail? It should have tried that group with 3 and succeeded. So let me reason through that. So if it's position 0 and there are 5 characters in groups 1 and 3, how does that work? We would have gotten to here. Wait, no, we would have when we debugged, we printed line 25, right? Yeah. So it should have done 0 plus 1 is 2. 2 to the length, so that should be from 2 to 5. With the next group should have just been a 3. Why did it not print that out? Oh, because I didn't print it out. So yeah, it should have just had those last 3 characters with a 3. So how does that? Spring's length is less than group. That's false. Next group should have been empty. For position is 0 to 3 minus 3 plus 1, so it should have tried position 0. The position, so that would not have broken. A position plus group, so 0 plus 3 is not less than 3. If it's empty, if it doesn't contain... Oh, shoot. It should be the remainder. If the remainder doesn't contain that. Okay, so then that's the bug. This actually moves this all moves into here. So actually I could just turn this around and say if it's greater than or equal to, then continue. And then remove that and not outdent that, right? So it can be exactly equal if oh wait. Shoot. This should be if it's greater than. Hold on. No, this is the exactly fitting scenario, right? So this is the next springs. Let next springs equal that. So it's if next springs contains that. I did that wrong. This should go there. Okay. Yeah, I should have like if next groups is empty. Um, this if it's not less than it only goes up to that. So yeah. Anyway, it'll be it's either less than or is exactly equal. Then it has to if it's exactly empty, then accumulation plus equal 1. And then either way, we're gonna continue. Okay, let's see if that fixed it. Nope. We get 88. Oh, because I'm still over counting. But at least we didn't panic this time. Yeah, so it tried fit into that, fit that. Oh, we're not seeing the accumulator values. That's okay. Um actually that's not okay. We should let's DBG it here. I want to see it actually count that one. So it doesn't count it yet, doesn't count it yet. And then it counted it. It skipped all the remaining positions, right? Right, okay. And then it shouldn't find any more positions. But okay, moving back, yeah. So we're not seeing the recursion. These are inner calls, and that's an outer call, right? Yeah. So it got the correct answer. Where did we print it? Right here. There's one fit, right? This next one is going to count too many of them. Yeah, okay, so it's the interior ones. So if I have to take the interior group, right? So if springs from position to position plus group, um, all, well, they have to all be, or there can't be any dot in there. So if it contains, not concat, contains a dot, then we'd skip it. Cares? Well, I didn't like that. Oh, there we go. Let's see if we counted right now. Hey, look, we got the correct number. All right, so then I can probably remove all my debugging. This one we need to keep the interior because we're returning that. All right, so run the test, should have no extraneous output, and then we're gonna run date 12 part 1, we get an answer. 7,090. It seems kind of low, but I mean, it could be right. Yay, it's right. Continue part 2. As you look out at the field of springs, you feel like there are way more springs in the condition records list. When you examine the records, you discover that they're actually folded up this whole time. To unfold the records on each row, replace the list of spring conditions with 5 copies of itself, separated by question mark, and replace the list of contiguous groups of damaged springs with 5 copies of itself. Okay. So for that would become that. I get it. First line of the above example will become that. In the above example, after unfolding, the number of possible arrangements for some rows is now much larger. Okay, so this might break our approach, right? It might break it, but I don't know. Maybe our solver is fast enough. Let's see. I kind of worried about it. Okay, so it's saying I guess this is solve 2 and this is solve 1. Or solve, unfold, and solve. Right? Um, unfold and solve. So it's we have to repeat it 5 times. So repeat. I thought there was a way you could repeat. Let's ask the ML. So in Rust, how do you repeat an iteration some constant number of times? Ooh, it's stumped. The artificial intelligence is stumped. Maybe we just need to reload. I think I stumped it. Maybe while it starts, it continues to try to answer it. I'll just log into ChatGPT after the site here. Maybe I just need to hit refresh, but let me type in the same thing into ChatGPT in Rust. How do you repeat iteration some constant number of times? In Rust, you can use a for loop with a dot dot range to repeat an iteration a constant number of times. That's not what I asked it. What I meant by repeat is to go through an iteration 5 times, such as 1, 2, 3 becomes 1, 2, 3, 5 times. Oh, it's cycle take. Okay. Yeah, this thing got stuck. I don't know why. So we want to do chars. We have to know the length of the original sequence, though. So we have to actually know. So let num springs springs.length. Oh, I'm doing it in the wrong place. And then we also need to know this. Actually, that we don't know. Can I get its number? Can I like let num groups equal groups length? No. Yeah, so I don't actually know the length unless I were to collect it first. I guess we could collect it. Just so we could count it. And then number of groups. Yes, so then groups is groups into iter cycle take num groups times 5. Okay, and then for springs, the same thing. This one. Num springs. Okay. Except for I have to chain it, right? I gotta put this thing is totally broken. What if I just hit reload? Yeah, it's like lost its mind. Yeah, I need to like add a question mark between them. So I can't just do chars. I have to do dot chain with standard iter once question mark. And then I have to add 1 to that times 5 and then subtract 1, right? Because we don't want a final question mark. We're adding 1 because we added 1 at the in between each one. Okay, so let's see if I get the right answer there. Yes. Okay. So now, will this run in fast enough? This one might not run fast enough. Shoot. So brute force is not working for us. How many lines does it have to get through? 1,000. So like we could have it print something, but when it gets one of them done, just to see if it's worth waiting for. So let's just edit while it's running. So yes, right here, let's do a dbg that. Well, let solution. Okay. Oh wow, this is really slow. That first line was pretty quick, but this one's really slow. And this one's even slower. A billion? 1.6 billion fits? And this one's even more? Wow. Okay. So our brute force solution is not going to be fast enough. So we had to think of like a better way to solve this. Actually, it's the same thing repeating, right? It's the same thing repeating, but hmm. But we have positions where it has to be locked down at some point, right? Well, that fourth line, it's really struggling on. It got the first three lines, but this fourth one is just stuck. I'm guessing because there's just so many unknowns. Well, I'm gonna take a quick break and think about it, and I'll be back in a minute or so. Oh, look at that. There's actually one line that only had one solution in it. Which one was that? One, two, three, four, five, six, seven, eight. This one only has one solution. Interesting. Okay, but I did think about a way we could speed it up. So there's an example here, right? If we're repeating it 5 times, Um, and we know that for every comma, there's basically a dot. It has to be a dot. We could add up those numbers, and the commas add one for the number of commas, and say that the remaining characters have to be at least that long. Otherwise, don't even try. So that would I think that would cut down on a lot of the combination searching. So I'm gonna try that. Maybe while this is going, the other thing I want to do is I want to print the number we're on. So I'll just let that go in the background. It's still going, right? Yeah. While that's going in the background, I want to change this a little bit. Let's have it print out the n u size, and so that we're going to do an enumerate. Actually, then what I want to do here is I want to do an input is that. Can I do that? No, I have to do this. Yes, so then I'm going to debug and end the solution. Okay, just to make sure that that actually gives me row numbers. Yes. Okay, so let's try to put in that optimization. So that's in the solver. Basically, we want an early break. So if the like the subset that we would get back is this, right? So if springs dot length minus, actually we can do it down here, right? Can do it right here. If length minus position minus group minus 1 is less than the total of the groups, so plus the number of groups minus 1. So next, I guess I could put it in here. Next groups dot length minus 1 plus next groups iter sum. Then we can break completely. Why does it not like this? Is it a type problem? Sum as u size. Okay. So okay, let's go ahead and cancel. I already canceled it. This shouldn't break the tests, I don't think. Except for sometimes that button stops working and I have to go back and open it again. Yeah, so it didn't break it. But hopefully it'll run faster now. Okay, it did get that row 1 much faster. But that row 2 that took like a minute or so is still taking a long time. Oh, no, it's faster. Okay. So if we can get to 1,000, we get our final answer. But it's still too slow, right? We're still on row 12. We don't want to wait till 1,000, do we? So can I think of like another optimization? Basically, the more places we can break in this loop, the better. It's on row 60 now. If we just get to 1,000, then we have the final answer. It's just still too slow. So line 61, right, is really slow for some reason. Why? Aha! It thought I was doing this, right? Just like if I do this, it's gonna do the lasers behind me. Oh, it's getting further. So line 77 is getting. Oh no, it's on 103 now. 129, 137. I could just let this run now. Apple's doing his thing, yeah. So 138, it's getting. So why would it get stuck on that? I'm guessing there are just a lot of places it could be in, right? I don't know. It's not really coming to me because okay, there's obviously okay, no, that could be a 6 or a 2 if it's repeated out here somewhere, right? But if we're adding question marks between them, that doesn't like really allow us to do much more insight. It's not really that insightful, right? This one is particularly hard for my algorithm to break. What else could I do here? Two, I think it's because the 2 could fit on the fold here that it's having trouble seeing that. Yeah, I don't know. Maybe I just let this run overnight and it'll have an answer in the morning. At this point, like it's a tenth of the way through there, right? I could just let it brute force its way all the way to the end. What it's going to come down to is, can I think of a more efficient solution faster than my current solution can solve it? I don't know. Look at the problem again. Maybe there's a hint in here somewhere. Yeah, I don't know. It's stuck on row 138, right? Oh wait, no, I think we're off by one because the first one was 0, right? Yeah, the first one is 0. Oh no, it got further. It's on 148 now. 150. 153. So 153, that's really the answer to 154. So it's stuck on this one again. Okay, so it's getting stuck on rows where there are a lot of small numbers, which I guess makes sense. Just wondering, like, if there are a lot of small numbers, that means there are a lot of things that have to be a dot. But see, this one doesn't have any, like, it doesn't really help us at all. There's so many ways that that could fit, right? And five, repeating it 5 times doesn't, it just makes it the amount of time to the power of five or more. Yeah, there's just so many solutions to that. Like, it's when it folds, does that mean like, does this one have to be within the first fold? If it does, then there's another optimization I could make. But if that one can start on in the second, like after the first fold, then like if the groups fit into the folded region, then it would be easier. It would be easier to do this. But I don't think that's true, right? I don't know. Has anyone solved this yet? Who's in chat? I might accept a hint at this point, because this, I don't know, I'm kind of getting to the point where this is not fun anymore. And how am I going to extract more fun without like a eureka moment or a hint, right? So I'm stuck on this one because we have to add one. So that means to solve 154 is this number. So it's stuck on 155 because there are so many small numbers and there are no hints in the pattern. Here's one thing to consider. Could I rewrite this? This is the number of damage. Could I rewrite this as the number of undamaged? Like invert it in some way? How many total characters are there here? 15. 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 15 extra undamaged, right? 6 damaged and 9 undamaged, right? So like 3, 4, 5, 6 damaged, 9 undamaged, and we know where 2 of the undamaged ones are. Does that help at all? I don't see how that helps. Yeah, I don't know. I don't know. Looking for a hint, I guess, at this point. Hmm. Hmm. Is there something I can do, like maybe like this came down to like fitting 3, 2, 1, like finding the number of combinations, right? And that's sort of what we're hitting here with line 155 is that what is this day 12 thing? Is there someone else streaming with code and the files listed as day 12? It's Advent code. Here, we'll give you the link. So every day from December 1st to 25th, you get a programming puzzle. It's made by a guy by the name of Eric Wassel. He actually codes up the server in Perl. It's a trivia fact. He does this every year, and let's see, how do we get like it's gone on since 2015. Every year you get 25 puzzles, and 2020, 2021, I did all 25 days, so you get two puzzles per day. And last year I kind of gave up after day 4 because I got distracted by life. This year I'm trying to do it every day, but right now I'm stuck on day 12, part 2. So the program I wrote to solve this puzzle, like it starts with um, this input up here, and it follows these rules, and it gets an answer, and then part 2 made it harder by just multiplying by 5 the length of everything, so that becomes, or sorry, this becomes that, and like the first line there turns into that. So it makes the problem a lot harder to solve the way I tried to solve it. With the example, it can solve it like immediately, but what you get for your real input is like a much larger thing. It's 1,000 lines, not 5 lines, and that's so that you don't solve it by hand. And that's proving to be really difficult. So my program right now is trying to solve line 155. It's off by 1, so like it started with 0, whereas my editor starts with 1. So when it says it solved 153, it really solved line 154, and it's working on 155, and it's been like that for many minutes now. If it could get to 1,000, I could get an answer and score a star for the day. But if it doesn't ever get there, like I have no idea how long this might actually take. It could take minutes, it could take hours, it could take years. Um, and I'm looking back at the instructions to see if there's maybe a hint or an idea in here about how we might solve it. Sometimes the examples will give you like a hint. Yeah, so generally the puzzles every day, they get harder and harder. So like day 24 is usually the hardest, and then day 25 they usually give you a really easy one, like click this button and then you get a star. It's like, oh, we don't even actually have to do any work. Um, so it's gone pretty well. Day 5 I kind of got stuck on a little bit, and we're smooth sailing, and now we hit day 12 part 2, and I'm really stuck. Unless this like gets past line 155, where is it gonna get hit? Where's the next bottleneck gonna be? Maybe that one. Oh, this one probably. This one's gonna be tough. It's these question marks are where like you don't know if it's a dot or a hash mark, right? So this one's really hard because there are no hash marks to give us a hint, and we're really relying on those. Maybe if I just maybe used the dots more, maybe. So the dot has to be in a gap, right? Hold on. I just thought of something. This first one, right, has to be here, doesn't it? No, 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 it doesn't have to be. Oh, but once we find a position where it has to be, it can't. Can it be the next one over? It could be. Never mind. Yeah, so we literally don't know where to look for this first one because it could be anywhere in here because we copied it 5 times, right? And what did I say that this is 15? And this what the sum of this is 2, 3, 4, 5, 6. So that means there are 9 dots. There are 9 dots and 6 hash marks in here. But repeat that 5 times, right? So who knows? 6. Right, so there are 5 extra dots. And they can be placed anywhere. I keep thinking like the way I'm trying to do it now is I'm trying to fit hash marks in there, but what if we turned the problem around and tried to fit dots? The rules get a little bit different, right? Um, you can have any number of dots. The dots fit these commas, right? The comma means one or more dot. I just thought of something. Isn't this just a regular expression problem? So this means hash mark, one hash mark, one or more dots, 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 2 hash marks. And a question mark can match either one, right? So it's really just a pattern match between these two. They're just expressed differently. Oh, that was the hint. They said up here in part 1, like way at the beginning too. Duplicated some of this information in a different format. I think that's the hint. Is that we're supposed to think of these are really saying the same thing, only different ways. And we're trying to fit the two together. Trying to find all the ways in which these two fit together. Yeah, I have a feeling that line 155 takes on the order of years, not minutes. Because it's been going for a good 10 minutes now, hasn't it? No, I am inclined to just let it run overnight and just end the stream and look at other people solve this instead. Cause maybe it's not on the order of years. Maybe it's just a couple hours and it'll get past line 155 and then it'll get through the rest of them quick. I could always hope. There's always hope. Hmm. I'm wondering if we solve one row, does it help us on any of the other rows? I think the answer is no. If we solve one row, it really doesn't help us on any other row. They're all independent, right? Yeah, I think I'm done. I think I'm just gonna let this run overnight and maybe I get the answer. Um, yeah, I've had it. So let's go find someone else who's still working on it. Hey, maybe while we're watching someone else work on the solution, I'll get a hint from that and then solve it for myself. That's not cheating, is it? Bad Cop was in here earlier. Bad Cop's working on it now. Is anyone else? Alka, Temporalix. It's the same people that generally have been solving it every night on time. Okay, then I don't really feel too bad raiding the same people. If the same people are playing, then we'll raid the same people. Okay, let's go switch to Bad Cop and see if Bad Cop's any further along in this than I am. Sorry that I couldn't get the solution live, but I'm not giving up. I'm gonna let this run. I'm gonna let it roll. Maybe next year it'll be done. But I'll see you guys later. Bye.